The majority's overall conviction, analysts say, is that the theory about how things came to be remains the major explanation for the beginning of the universe. This speculation connects the movement of stars, planets, and, furthermore, life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang provides an instructive evaluation concerning what could have happened at first. The universe was extremely dense, compressed into a tiny space, more dense than a pinhead, with particles tightly packed. From this moment, a giant impact of matter and energy occurred, the Big Bang. This event, happening billions of years ago, set off the expansion of the universe. In any case, according to available scientific data, it has sparked new peculiarities. With the assumptions of this theory, when NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory of all time, specialists estimated that its discoveries would confirm the theory of the universe's origin. Within just 1 year in space, the telescope shocked specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's stunning capabilities have uncovered countless galaxies, going as far back as a time so ancient that it challenges our understanding of the origins of the universe. This revelation sparked intense debate about what may have existed before the Big Bang. One critical moment in this mission occurred when cosmologist Rohan Naidu, working with data from the telescope, unexpectedly tracked down a system that formed shortly after the Big Bang, making it the most distant galaxy of all time. Naidu's discovery shocked the scientific community, highlighting the remarkable capabilities of the James Webb Telescope. Its enormous mission to reshape our perspective on the universe has only just begun, promising dazzling insights into the earliest periods of the universe's existence. This barely explored era holds the key to understanding the formation of the first stars and galaxies. The telescope's discoveries have clashed with foundational theories, uncovering systems whose properties exceed previous assumptions. This extraordinary surge of early galaxies has ignited a storm of scientific inquiry, challenging experts to reconcile these findings with existing theories. As researchers catch up with these discoveries, they face key questions about the nature of the universe and the forces that shaped its evolution. Beyond the telescope's obvious advantages, it is located 1.5 million kilometers from Earth, shielded from cosmic interference and cooled near absolute zero by its tennis court-sized sunshield. The James Webb integrates a massive mirror and astonishingly sensitive instruments designed to uncover details of the early universe that were previously hidden. This period, known as the Cosmic Dawn, occurred around 200 to 300 million years after the Big Bang, marking the time when the first stars and galaxies began to form. How this process unfolded remains a subject of intense study, involving theories about dark matter, dark energy, and interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn offers a unique opportunity for cosmologists to test and refine their understanding of these complex processes. By studying these ancient systems, scientists are faced with two options: affirm the validity of current models, or identify knowledge gaps that could lead to major new discoveries. At first, the telescope's objective was to observe a few weak and small galaxies in its pilot studies. However, the reality has far surpassed those expectations. The telescope's early images of the distant universe revealed a wealth of galaxies with ages, sizes, and brightness levels that defied all predictions. This astonishing wave of early galaxy discoveries has sparked a race among astronomers to set new records for the earliest known massive systems. With new revelations constantly emerging, conventional experts are left in awe. Following the James Webb Telescope's discoveries, topic specialists and observers rushed to analyze the presence of these surprisingly advanced early galaxies. There was some speculation that the telescope's interpretation of immense observations might be responsible for these startling results. That said, the consensus remains. These findings represent a paradigm shift in how we understand the early universe and offer thrilling glimpses into the potential for vast scientific progress. The new information discovered by the James Webb Space Telescope about galaxies has raised important questions about the nature of the universe and challenged the assumptions of standard cosmological models. While some experts are working to reconcile these insights with existing theories, others suggest they may be the first signs that the universe is much more complex and mysterious than previously imagined. The crucial question at play is our fundamental comprehension of the universe itself. The early discoveries of the JWST could reshape our core ideas of cosmic history, revealing insights not only about distant galaxies and ancient structures, but also about the intrinsic nature of our own Milky Way. As Mark McCaughrean, Sr., advisor for science and exploration at the European Space Agency, put it, "You build these machines not to confirm theory, but to break it. You just have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, before the launch of the Hubble Space Telescope. At that time, Garth Illingworth, then head of STSCI, was tasked with envisioning what might come after Hubble. Despite initial doubts, Illingworth and a small team began laying the foundation for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much deeper into space. This capability is critical for studying distant galaxies, whose light has been stretched into infrared wavelengths due to the universe's expansion, making them invisible to telescopes like Hubble. With its massive, cold, star-like mirror, the JWST became the most powerful tool yet for uncovering the secrets of the cosmic dawn. The need for such a telescope was highlighted in 1995, when the Hubble Deep Field observation revealed countless galaxies in what was once believed to be a void in the sky. This discovery revealed the early universe's richness and underscored the need for a telescope capable of probing far deeper into astronomical history. After 20 arduous years of development and a cost of around $10 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most important year of scientific observation. Early initiatives, such as the Early Release Science Program and the General Observing Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. WST observations have challenged long-standing cosmological models, revealing galaxies that defy traditional expectations, laying the groundwork for a revolutionary new chapter in humanity's understanding of the cosmos. Highlighting the importance of pushing the limits of scientific investigation. And showcasing the exceptional capabilities of the most recent technologies like the James Webb Space Telescope, JWST, scientists continue to investigate JWST data. They may uncover further insights that challenge us and improve our comprehension of the universe. At the time the initial data began coming in from the JWST, cosmologists eagerly awaited the results. Many had been preparing their data analysis pipelines for this moment for many years. Rather than following the traditional system of peer review, which typically takes several months, experts chose to share their discoveries on preprint servers like arXiv, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new form of peer review to take place through online platforms like Twitter, where established specialists could quickly discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of discussion was both extraordinary and intense. However, there were also concerns about the potential drawbacks of this rapid dissemination of results. Klaus Pontoppidan, a JWST project researcher at STSCI, cautioned that while the fast sharing of results facilitated quick discussion and dissemination, there was also the risk of overwhelming the process. The general agreement among most specialists is that the theory of how things came to be remains the primary explanation for the beginnings of the universe. This speculation joins the development of stars, planets, and life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang provides a persuasive explanation for what might have happened at the universe's beginnings. The universe was once densely packed into a space less than a pinhead. From this, a huge burst of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history into motion. However, changes in data science have led to developing anomalies within the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, analysts estimated that its observations would support the prevailing theory about the universe's origin. Tragically, or rather, surprisingly, after only 1 year in space, the telescope astonished specialists with its ability to peer deeply into the universe's past. The JWST's amazing capabilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the origins of the universe. This discovery sparked a serious examination of what possibly existed prior to the Big Bang. The James Webb Space Telescope's findings have challenged long-held beliefs about the universe's beginnings and posed brand-new inquiries that reshape our understanding of cosmic history. The telescope's discoveries suggest that the universe may have evolved in ways previously unimagined. For instance, the fact that galaxies exist at an age far earlier than previously thought has caused astronomers to reconsider the timeline for galaxy formation. These early galaxies appear far more mature than expected, showing features such as rapid star formation and complex structures, traits believed to occur much later in the universe's history. Scientists are now investigating how these primitive galaxies might have formed so quickly, and whether their evolution could provide insights into the processes that gave rise to the first stars and the earliest cosmic structures. The discovery of such galaxies so early in the universe's history has implications not just for galaxy structure, but for the broader understanding of cosmic evolution, including the role of dark matter and dark energy. In addition to the James Webb's capacity to look further into space than ever before, the telescope has revealed previously hidden features of the universe. Among these are faint signals from the very first stars. Observing these illuminates the early universe, the cosmic dawn, the period when the first stars began to form and ignite. This is an essential step in understanding how the universe transitioned from a dark, uniform state to the complex, structured cosmos we see today. Another aspect scientists are studying closely is the role of black holes in the formation of early galaxies. The JWST's detailed images suggest that supermassive black holes, once thought to require billions of years to form, may have developed much earlier. These findings challenge previous theories about how black holes grow and influence their environments. Some experts believe that the presence of these early black holes could be connected to the rapid growth of galaxies during the universe's infancy. As astronomers continue to analyze data from the JWST, they will undoubtedly encounter more surprises that may force revisions to current cosmological models. The discoveries made so far have only scratched the surface of what the telescope is capable of revealing. Every new piece of information deepens our understanding of the universe's origins and brings us closer to answering one of the most important questions in science. How did the universe begin? What existed prior to the Big Bang? Toward the cosmic future that lies ahead, the telescope's mission, still in its early stages, promises to provide additional groundbreaking information that could result in a significant shift in how we understand the cosmos. With its unprecedented ability to observe distant galaxies, stars, and other celestial objects, the James Webb Space Telescope is not just a tool for testing existing theories, it is a gateway to new discoveries in the quest to uncover the universe's deepest secrets. As scientists continue their research into the early universe, the knowledge gained from the telescope will undoubtedly challenge existing paradigms and offer new directions for research in physics, astronomy, and cosmology. Ultimately, the discoveries made by the James Webb Space Telescope are likely to provide profound insights into the nature of the universe, its origins, its evolution, and its future. By revisiting some of the most fundamental questions in science, the telescope is helping to unlock a new era of cosmic exploration, where the mysteries of the universe are no longer hidden in darkness but are being revealed, one discovery at a time. The telescope's ongoing contributions to science may be the key to understanding the full extent of the universe, its vastness, its structure, and the forces that govern it, forever changing our place within it.